Okay, today we are going to discuss a very important topic in mathematics, and there are so many applications in this topic. Uh, if you say in mathematics, statistics, even economics, and a lot of streams, this particular subject or this particular theory part is very important. So I will make a start with historical approach. You know, the famous story, the apple fallen to the head of our famous scientist. The name is Sir Isaac Newton. So this particular concept start from that particular era. So when the apple fallen to the head of this particular scientist, so he firstly found the gravitational force, so that we do some calculations in our theoretical parts. But after that, he want to study about the things that are moving. Today in our vehicle, the speedometer is available. We can find out the speed at a given moment. But those days, the speedometers were not there. Therefore, the people could not find the exact speed at a given point. But they calculate the average speed. So this particular scientist, he knew the speed is changing from time to time. Then he want to calculate a concept to find what is the instantaneous velocity. Velocity means that it's a speed. What is the instantaneous velocity? So he tried to think about this concept, and he found a particular formula. So today we are going to discuss a broader topic, calculus. In the calculus, we are learning differentiation and integration. There are basically two parts. So the two parts are the major components, differentiation and integration. So in our new syllabus, the previous only the differentiation is there, but in our new syllabus we have to study, fortunately or unfortunately, both in differentiation and the integration. So in our syllabus we need to study, yes, differentiation and integration. Then we need to study the application part of this particular concept, that is averaging marginal cost, marginal revenue using the differentiation. And the second one, under the integration, we have to learn averaging total cost and the total revenue using the integration, profit maximization and profit minimization. So we are learning this topic under these three sections. Basically, we firstly learn what is differentiation and what is integration. Then we learn how to calculate the marginal cost, marginal revenue, marginal profit from the differentiation. Secondly, we calculate the total cost and total revenue by using the integration functions. Not only that, we need to find out a maximum and minimum point. Say, for example, the company objective is to maximize profits. To maximize profits, there's a particular concept. In the differentiation, we can find, if we know the profit function, we are learning how to derive the profit function. By using the profit function, we maximize the profit. In terms of the cost, we need to find out the cost minimization. So the cost minimization, again, we can find from the differentiation function. So we are learning firstly the theoretical part of differentiation and the integration. Secondly, their applications. Right. So write down the topics, calculus, the broader topic, and under that, differentiation and integration. So kindly turn to the page number 15 of your book. I have given you the basic introduction about the historical background. So the differentiation. Okay. Now, coming from the first principle says the differentiation is they have calculated using the velocity. If we take a particular graph like this, a constant gradient, the gradient is constant, the slope is constant. If the slope is constant, we know the formula y is equal mx plus c. See, this m is constant. Now we can calculate, say for example, this is the distance and this is the time. Then we can easily calculate the speed. If it is a constant speed, we can calculate the difference between y-axis and difference between x-axis. So we say this is y-axis difference and this is the x-axis difference. So the gradient that is equal distance, that is difference in y-axis divided by difference in x-axis. Difference in y-axis divided by difference in x-axis. So that is the gradient. So basically what is the difference in y-axis? That is the distance. Difference in x-axis, that is the time. Distance divided by time, that is, we know that is the speed. So we can get the speed delta y divided by delta x. So this is the delta y and delta x. Delta in the sense a small distance divided by small time. So delta x divided, this is the speed. This is not a problem. We can calculate the average speed. So we can take the total distance traveled divided by the total time. From that we can calculate the average speed. But this is not the problematic one. We need to calculate, we know our vehicles, we are starting from the zero velocity, zero speed. When we accelerate, the speed will increase, and in a particular point, we start going in a particular speed, maybe 60 kilometers per hour or 70 kilometers per hour, whatever the speed, and again we apply the brake, it is coming down and coming down to the zero. Therefore, the speed is changing in every moment. This one, average speed. So for example, if we, in our highway, we start from going from the Kot Tower to Galle. We start zero velocity, zero speed. We increase our speed up to 100 kilometers per hour. Say for example, we'll travel the whole distance or whole period, say 100 kilometers per hour, and we apply the brake at the Galle. And it's again coming down. So the speed changing, so we can draw a function like this. Now how do we calculate the constant, non-constant? The gradient is not a constant. Gradient is changing. If the gradient is changing, say this is the time and the distance, time and the distance, this is changing. How do we calculate the gradient? So the gradient at that particular moment is this one, this one, the gradient is changing, the slope is changing time to time. Then we need to calculate a gradient. How do we calculate? Again, the same concept. We take a particular point, say this is coordinate, x coordinate, and this one is y coordinate. We take a small increase of time, so we say delta x, x plus delta x, x plus delta x. Delta x is a very small one. We need to calculate the speed at this particular point. To calculate the speed at this particular point, we obtain x plus delta x. So, and the time we say y plus, sorry, the distance is y plus delta y. Now the speed is difference in y-axis divided by difference in x-axis. Okay? So difference in y-axis divided by difference in x-axis. You don't have to write this because that is already given in your handout. So explained there. And for the examination concern is also not very important. Just to have an idea what is differentiation. So in your handout, it is well explained in the page number 15. Okay, so here, again I am going to calculate the speed. What is the speed? I'll put speed here. Speed is equal difference in y axis divided by difference in x axis. Difference in y axis divided by difference in x axis. So what is the difference in y axis? Look at this one. Y plus delta y minus y divided by difference in x axis. So what is the difference? So here to here x, here to here x plus delta x. What is this difference? X plus delta x minus x. X plus delta x minus x. So we write here x plus delta x minus x. Now we can simplify y plus delta y minus y, that is y and y we can cancel. The answer is delta y divided by x plus delta x minus x, so that is delta x. But we need to calculate the speed at this particular point. Say this point is P. We need to calculate the speed at P. It's continuously changing. Therefore, we apply the limit. The limit, this goes to the limit. Delta x goes to 0. We make this point closer, 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 closer to the x value. So when this comes to the closer, the delta x goes to 0. That means the difference is becoming small, small, smaller, 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 and again it goes to 0. Not exactly 0, but it goes to 0. Then what happens? Dy delta y divided by delta x, right? Delta y divided by delta x. So this is the gradient. We'll denote it by m. Gradient is, the notation is m. So m is equal limit delta x goes to 0, delta y divided by delta x. So the Newton, that particular scientist, found the formula this one. Delta y goes to delta 0. The limit of delta y divided by delta x, he denoted it as dy by dx. That is the differential coefficient. Differential coefficient. So this is the differential coefficient. So up to here, all are theoretical part, not the computations. So what we need to study, the computations for our examination concern, for our application questions to be simplified, we need the calculation, right? Up to here, the theoretical part, the approach, how this becomes dy by dx. What is important is the gradient. We are going to find out the gradient by using the differentiation. So the gradient m, limit delta x goes to 0, delta y divided by delta x. We denote this as a special name dy by dx. We pronounce this by dy by dx. So now we are going to calculate real calculations, see real mathematics questions, okay? Now the formula, if you consider y is equal x to the power n, this is a function, y is equal x to the power n. If the function is y is equal x to the power n, what is the value of the differentiation dy by dx? We are going to calculate the value of dy by dx. Differentiation is dy by dx. So the formula, we have to remember this, nx n minus 1. What is the formula? Nx n minus 1. So this n comes into the front. X n minus 1. The power is n minus 1. So write down. Consider under the differentiation. Topic is differentiation. Under the consider any function y is equal x to the power n. Consider any function y is equal x to the power n. The differentiation of this function is given by, differentiation of this function is given by, under that write down, y is equal x to the power n, dy by dx equal nx n minus 1. Nx n minus 1. So this is a very, very important formula. So we are working out all these differentiation questions by using this basic formula. So the basic formula is dy by dx is equal nx n minus 1. Right. Now we will practice some questions. In your handout also I have given some questions, but I will give fresh questions here. You can practice them as a homework. Okay. Question number 1. How are we going to use this formula and mathematically calculate the differentiation? Say if I consider y is equal, a very simple function, y is equal x squared. Y is equal x squared. How do we differentiate? So we need to identify the n. X to the power n. Look at this one. X to the power n. X to the power 2. How much is n? N is equal to. Right? N is equal to. How do we differentiate? Once you differentiate, you have to write the symbol dy by dx here. Dy by dx. Dy by dx is equal n is equal to 2x 2 minus 1. So that is 2 minus 1 is 1, x to the power 1 is x. So 2x. The answer is 2x. Differentiate x squared, your answer is 2x. Write down this. First example. Y equal x squared differentiation. That is 2x. Second one. Y is equal x to the power 5. How do we differentiate? Again, we identify the value of n. That is the only thing we need to identify. N is equal how much? N is equal 5. N is equal 5. Then differentiate. How to differentiate? Yes, dy by dx. That is equal. N come to the front. 5x 5 minus 1. 5x 5 minus 1. So answer 5x to the power 4. Third one, y is equal x to the power, say for example 2001, a big one. 2001. Differentiate this one. Identify the value of n. So how much is n? n is equal 2001. Okay, so differentiate dy by dx equal, yes, 2001 comes to the front, so 2001 x 2001 minus 1. So that is equal 2001 x to the power 2000. That's all. So whatever the value, don't worry about this value. The rule is nx n minus 1. So you have to by heart the formula. Y is equal, x to the power n becomes dy by dx equal, what is the formula? Nx n minus 1. So you have to remember nx n minus 1. Now we'll move to the next question. Question number 4. Shall I put something like y is equal x to the power minus 7? All these questions x is positive. Now y is equal x to the power minus 7. The same procedure. How much is our n? Our n is equal minus 7. So dy by dx equal, yes, n is equal minus 7x minus 7 minus 1. Minus 7 minus 1. Answer dy by dx equal minus 7 x to the power minus 8. That is the answer. Minus 7 x to the power minus 8. Now we'll move to the question number 5 again, another one. Y is equal 1 divided by x to the power 5. What is this? 1 divided by x to the power 5. These questions I have put in the denominator. Recall the memory indices. If we have something in the denominator, and if you want to take it to the numerator, how are we going to do? We change the sign. So we have done called x to the power minus m, that is equal 1 divided by x to the power m. The negative indices, you take it to the denominator, that becomes positive. Positive index, you take it to the numerator, that becomes negative. Therefore, to the power 5, when you take the whole set into the numerator, this becomes y is equal x to the power minus y is equal to the power minus 5. Now you can apply the formula. dy by dx, that is equal, yes, dy by dx, that is equal, yeah. You need to identify the value of n. N is equal minus 5. Minus 5 x to the power minus 5 minus 1. So minus 5 x to the power minus 5 minus 1 minus 6. So the answer minus 5. Yeah, the negative answer. Why negative answer? Because the power is minus 5. So minus 5 comes to the front. So that is minus 5 x to the power minus 5 minus 1 minus 6. Okay. Next one. Write down these examples. Okay. Question number 6. Y is equal x to the power 3 over 2. Is equal x to the power. First, the power with positive values. Secondly, a negative value. And thirdly, a fraction. What is a fraction? Y is equal x to the power 3 over 2. Again, thus differentiation dy by dx equal, here the power is 3 over 2. It comes here 3 over 2 x 3 over 2 minus 1. The same procedure. What is the same procedure? Nx n minus 1. So you identify the value of n. The value of n is 3 over 2. So 3 over 2 x 3 over 2 minus 1. So this is equal 3 over 2 x to the power 3 over 2 minus 1. So here 3 over 2 minus 1. 1 means 2 divided by 2 because I want to make it a common denominator. So 1 over 2 is the answer. So 1 over 2. Write down this one. And can you do this one? Y is equal x to the power 3 over 4. I'll write it again. Question number 7. Y is equal x to the power 3 over 4. Yes. Again, identify the value of n. So n is equal 3 over 4. So dy by dx, that is equal 3 over 4 x to the power 3 over 4 minus 1. 3 over 4 x to the power 3 over 4 minus 1. So this is equal 3 over 4 x 3 over 4 minus 1. Minus 1 means 4 over 4. So that is minus, here 3 minus 4 is minus 1 over 4. So the power is how much? Minus 1 over 4. This is the answer. Next one, question number 8. Y is equal, say third root of x. What is this one? Third root of x. Third root of x. So you can write this as y is equal x to the power 1/3. Y is equal x to the power 1/3. Again the indices, the rule of indices, right? Y is equal x to the power 1/3. So now we can differentiate. So with the square root sign we cannot, with the root sign we cannot differentiate. When we convert that into the power by dx, so that is 1/3 x to the power 1/3 minus 1. 1/3 1/3 minus 1. So this is 1/3 x to the power minus 2 over 3. If I take, say, y is equal just square root x, square root x, nothing, square root x. Yes, what is square root x? Y is equal x to the power half. Square root x means that is half. So dy by dx, yes, dy by dx equal, n is equal half for half x half minus 1. The rule is nx n minus 1. Nx n minus 1. So half x half minus 1. So the answer is half x minus half. Half x minus half. Question number 10. fourth root of x to the power 3. Fourth root of x to the power 3, the root 4. So how do you differentiate? Dy by dx equal, first remove the root sign. When you remove the root sign, what happened? 3 over 4. You can remember x to the power nth root of x to the power m. In the indices we have done it. Nth root of x to the power m, that is equal x to the power m, x to the power m over n. That is the rule of the indices. By using this rule, nth root of x to the power m, x to the power m divided by n. Similarly here, fourth root of x to the power 3, x to the power 3 divided by 4. The 4 comes as the denominator. 3 is remaining as the numerator, but 4 comes as the denominator. Now we can differentiate. Sorry, we can't put the differentiation sign. We haven't differentiated. We have written by using the form. So y is equal x to the power 3 over 4. Now we differentiate dy by dx. Once you put this differential coefficient, this is a differential coefficient. When you put the differential coefficient, that is the point where we differentiate this function. So this is equal, yes, 3 over 4 x to the power 3 over 4 minus 1. 3 over 4 x to the power 3 over 4 minus 1. So this is equal, yes, 3 over 4 x to the power minus 1 over 4. 3 over 4 x to the power minus 1 over 4. Okay. One last question. Question number 11. Y is equal 1 divided by third root of x to the power 5. Third root of x to the power 5. 1 divided by third root of x to the power 5. So you can write this as y is equal 1 divided by x to the power 3 goes as the denominator, 5 divided by 3. 1 divided by x to the power 5 divided by 3. Now I will take this to the numerator, then this becomes y is equal x to the power plus 5 over 3 becomes minus 5 over 3. Now we can differentiate dy by dx, yes, dy by dx, that is equal minus 5 over 3 x to the power minus 5 over 3 minus 1. So this is equal minus 5 over 3 x to the power minus 5 over 3 minus 3 over 3 minus 5 minus 3 minus 8 over 3. Minus 8 over. Okay, so we have done fair amount of questions. Firstly, the positive values, secondly, negative values, then the square root values and values in the denominator. So we have covered sufficiently for the first rule. Now we are moving a little bit because we don't see always the function like this. Some functions we are having the coefficients in front of the variables. There are coefficients. Okay. So before that, I would like to introduce a notation. See, this is our rule. Y is equal x to the power n. We call this is a function of x. This is a function of x. So I can write this y is equal function of x. So what is this one? Y is equal x to the power n. What is x to the power n? X to the power n is a function of x. So we can fx. Y is equal fx. Now when you differentiate dy by dx, we can write this as a notation f dash x. This is called f dash x. So this is f dash x. So that's a notation. So dy by dx is a notation of, sometimes they will give you fx is equal x to the power 10. Calculate the value of f dash x. So you need to identify the f dash x. F dash differentiation. So nothing you have to do. Again, differentiate 10x, 10 minus 1 is 9. So the symbol is f dash x. When you see the symbol f dash x, that is a differentiation of this function. Again, we are differentiating this function with respect to the x variable. We call this is a x variable. We are differentiating with respect to x variable. Then the question arises, if not, if some other variable, like say a time dependent function, maybe a cost function with the quantity dependent cost function. So we'll come back to that bit later. Before that, I want to highlight with the coefficient, say y is equal c times fx. What is this one? Y is equal c times fx. So in front of the variable x to the power n, basically, we have another coefficient, that is c. We have a coefficient c. So how do you differentiate this one? X, that is equal, right? Keep the coefficient as it is. Don't do anything. This is a numerical value. Keep this numerical value as it is and differentiate only the functions. When you differentiate the function, it becomes f dash x. Here, if you have a coefficient, that is maybe a constant or coefficient, we keep the coefficient as it is. We differentiate only the variables. We can't differentiate the values like this. 5. Say this is 5. So keep the 5 as it is. So we'll put some examples here. Write down this one. If a function multiply with a constant, then that becomes a coefficient. When you differentiate a function with coefficient, keep the coefficient as it is. Keep the coefficient as it is and differentiate only the variables. Differentiate only the variables. Okay, we'll do an example. Question number 12. The power 3. Now we can see in front of the variable there's another coefficient. We call this a coefficient. So in front of the function here we have x squared. So y is equal to x to the power 3. So now we have to differentiate dy by dx. How much? Keep the coefficient as it is. Don't do anything to the value of 2. Keep 2 as it is. 2. Differentiate this one. How much is our n? N is equal 3. So 3x 3 minus 1. Keep 2 as it is. 3x 3 minus 1. So this becomes 2 into 3 is 6x to the power 2. So the answer is 6x to the power 2. Here again, 2 is a constant, coefficient. So keep the coefficient as it is. Differentiate only the variable x to the power 3. So that becomes 3x 3 minus 1. So 3 into 2 is 6, 6x squared. 13, y is equal 5x to the power 5. 5x to the power 5. Yes. dy by dx. dy by dx, that is equal. Keep the 5 as it is. Differentiate x to the power 5. When you differentiate x to the power 5, 5x 5 minus 1. 5x 5 minus 1. So this is equal 5 into 5, 25 x to the power 4. 25 x to the power 4. Question number 14. Minus 6x to the power 4. Minus 6x to the power 4. So here we have dy by dx, that is equal. Keep minus 6 together with the sign. Keep minus 6 as it is. Keep minus 6 as it is. And differentiate x to the power 4. Our n is equal 4. So 4x 4 minus 1. So that is minus 6 into 4x to the power 3. Minus 6 into 4x to the power 3. So this is equal 6 into 4 minus 24 x to the power 3. Minus 24 x to the power 3. So that is the answer. Question number 15. Y is equal minus 2x to the power minus 6. Now the power and the coefficient both are negative. So differentiate this one. dy by dx. Yes. Keep minus 2 as it is. Minus 2 x to the power, minus 2 as it is. Multiply x to the power minus 6. So minus 6 x to the power minus 6 minus 1. So that is equal here minus 2 multiplied by minus 6. Minus minus becomes plus. So plus 12. So I don't need to write plus. Minus minus becomes plus 12. X to the power minus 7. Minus 2 into minus 6 plus 12. X to the power minus 7. Y is equal minus 4 divided by minus 2 x to the power minus 2. Minus 4 divided by x to the power minus 2. So this becomes y is equal, I will take this denominator. I can't differentiate with denominator, things with denominator. Therefore always you take it to the numerator. So minus 4 into x to the power minus 2 becomes, when you take it to the numerator, plus 2. X to the power minus 2 becomes x to the power plus 2. So now we have y is equal minus 4 x to the power 2. Now we need to differentiate this one. Apply the rule. dy by dx equal minus 4 into 2x 2 minus 1. I don't want to write 2 minus 1. 2 minus 1 is 1. 2 minus 1 is 1. So that is x power 1. I don't need to write 1. So here minus 4 into 2 minus 8x. minus 8x. Question number 17. This one. 4 into square root x, y is equal 4 into square root x. So dy by dx, or first y, equals 4 into x to the power minus half. 4 into x to the power minus half. So dy by dx, that is equal 4 into minus half x to the power minus half, sorry, it's plus half, not minus. Sorry, x to the power half. So half x, half minus 1. Half x, half minus 1. So you can simplify 4 with 2. So 2x to the power minus half. 2x to the power minus half. Question number 18. Four into fourth root of x to the power 5. 4 into fourth root of x to the power 5. So dy y is equal 4 into this, you can write x to the power 5 over 4. You can write x to the power 5 over 4. Now look at this. We can keep the coefficient as it is. So dy by dx, keep the coefficient as it is, 4 into here. Differentiate 5 over 4 x to the power 5 over 4 minus 1. Right, very clearly n x n minus 1. That is the only rule we have learned about the differentiation. N x n minus 1. So 4 and 4 you can cancel. So the answer is 5 x to the power 5 over 4 minus 1 is 1 over 4. 5 minus 4, yeah, 5 over 4. This is 4 divided by 4. 5 minus 4 is 1. 1 over 4. Okay. I will give a very simple one here. Question number 19. Say y is equal x or 5x. A very simple one. Y is equal 5x. Y is equal 5x. So what is the answer? Dy by dx equal 5 into, right? 5 is the coefficient, 5 into x to the power 1. Here we have x to the power 1. So 1x 1 minus 1. 5 into here 1x, 1 into x, same thing. X to the power 1 minus 1, so that is x to the power 0. X to the power 1 minus 1, the power is how much? 1 minus 1 is 0. So x to the power 0, how much x to the power 0? Any value to the power 0 is 1. We have learned under indices, any value to the power 0 is 1. So the answer is 5. Answer is 5. So no variable. Y is equal 5. Nothing. No variable. Y is equal 5. How do you differentiate? Y is equal 5. So without a variable we can't differentiate. only the constant y is equal 5. So what we here do, we know that x to the power 0 is equal 1. So we can write here y is equal 5 times x to the power 0. No harm, because x to the power 0 is equal 1. So we can write 5x to the power 0. 5x to the power 0. So we can differentiate now. Dy by dx equal 5 times, differentiate, our n is equal 0 now. 0 x to the power 0 minus 1. What happened? When you multiply something by 0, everything goes to 0. If you multiply something by 0, any value, that goes to 0. So dy by dx equal 0. This is a very important concept in future. So write down, put a star. Put a star and write down. When you differentiate a coefficient, when you differentiate a coefficient, the answer is always 0. The answer is always 0. When you differentiate a constant, you don't have to do anything. The answer is 0. Okay. So now, basically, we have done basic differentiation and differentiation with coefficients. The next step is, if you come across a function with more variables, like here, say y is equal, something like this, y is equal 2x squared plus 3x plus 4. A function with several, here x to the power 2 is here, x to the power 1 is here, constant is here. How to differentiate? So we are discussing under summation rule. In the summation rule, what we do here, say y is equal fx plus or minus gx. So consider, look at this again, a theory part. Y is equal summation of two functions here. Summation of fx plus or minus, maybe plus, maybe minus, fx plus or minus gx. How to differentiate? So we have to differentiate. So f dash x plus or minus g dash x. So what we need to do, we have to differentiate them separately. Here fx becomes f dash x, gx becomes g dash x. Fx becomes f dash x, gx becomes g dash x. So we'll do some examples here. Y is equal, say y is equal 4x to the power 3 minus 3x to the power 4. Y is equal 4x to the power 3 minus 3x to the power 4. How do we differentiate? We have to differentiate them separately. So dy by dx, that is equal, dy by dx, that is equal 4x to the power 3. So write the coefficient as it is, 4 into 3x to the power 3 minus 1. 4, that is a coefficient, keep it as it is, 3x to the power 3 minus 1. 3x to the power 3 minus 1. Minus 3 is a coefficient, you write it 3 into 4x to the power 4 minus 1. 4x to the power 4 minus 1. So you can simplify this. 4 into 3, 12x to the power 2 minus 3 into 4, 12x to the power 3. 12x to the power 2 minus 12x to the power 3. That is the answer. Okay, write down this one, the C part. Y is equal fx plus gx. So when you differentiate two functions, dy by dx equal f dash x plus or minus g dash x. That means differentiate the functions separately. Now, y is equal 4x to the power 3 minus 3x to the power 4. The differentiation is here. Write down this also. That should be the question number 21. Then 22. Y is equal 2x squared plus 3x minus 4. Okay, so we'll do the okay, this question, y is equal 2x squared plus 3x minus 4. So dy by dx, that is equal, yeah. So 2 is a constant, so 2 into 2x2 minus 1 plus 3 into here 1, 1x1 minus 1 plus minus 4. Minus 4 is a constant, so that becomes 0. No need to differentiate. Constants become 0. So dy by dx equal 2 into 2, 4, x to the power 2 minus 1. So that is x to the power 1 plus 3. So you don't need to put 1. So that is the answer, 4x plus 3. 4x plus 3. Question number 22. Question number 23. Y is equal 4x to the power minus 3 plus 3x to the power minus 4 plus 8. 23. Now differentiate this one. Okay, dy by dx, that is equal, dy by dx equal 4 into minus 3 x to the power minus 3 minus 1 plus 3 into minus 4 minus 4 minus 1 plus 0. Here 4 is a coefficient, keep it as it is. Differentiate this one, minus 3 x to the power minus 3 minus 1. So 4 into minus 3 minus 12 x to the power minus 3 minus 1, that is minus 4. 3 is a coefficient, keep it as it is. Minus 4 x to the power minus 4 minus 1. Minus 4 into 3, that is again minus 12 x to the power minus 5. So the constant becomes 0. Constant becomes 0. So the answer is minus 12 x to the power minus 4 minus 12 x to the power minus 5. Right. So we know how to differentiate now the variable, now the functions, not only the variable, the functions with several values. If I give you something like this, here 24, here y is equal 1 over 4 x to the power 3 minus 3 over x to the power 2 minus 2. Now the variables are in the denominator. So I will rearrange this. Y is equal 1 divided by 4 x to the power minus 3. How do you write this? I will take this x to the power 3 to the numerator. Right? X to the power 3 to the numerator. So that becomes x to the power plus 3 becomes x to the power minus 3. So x to the power plus 3 becomes x to the power minus 3. Here we have 1 over 4. Minus 3 is in the numerator, no problem. X to the power minus 2 also I have to take it to the numerator. So take it to the numerator, x to the power plus 2. X to the power plus 2. So this is equal, y is equal 1 over 4 x to the power minus 3 minus 3x squared. I can differentiate this now. Dy by dx 1 over 4 into minus 3x to the power minus 3 minus 1. I will straight away write minus 4. 1 over 4 minus 3 x to the power minus 4 minus 3 into 2 x to the power plus 1. So this is equal minus 3 over 4 x to the power minus 4 minus 6x. So we have basically covered the differentiation equations with several terms, 2 or 3 terms. Now the change of the variables. Now say if the function with some other variables, like practically we are coming across cost functions, revenue functions, profit functions, demand functions, supply functions. All these functions, our variables are not always x and y. Our variables are not always x and y. Say for example, if we have different variables, if we have, question number 25, say we have, say cost is equal 2q squared minus 3q plus 4. Now say a cost function. Cost function C is equal, cost is equal 2q is the quantity, 2q squared minus 3 into quantity plus 4000. a cost function. Now when you differentiate, as you can remember, always previous questions we differentiate with respect to the x variable. Now we don't have x variable and y variable. We are having c variable and q variable. So accordingly, nothing happened to the concept. Concept remains same, but the terms are different. So we write dc by dq. How do you write? dc by dq. Here, instead of y we now have c. Instead of x we have now q. So you write dc by dq, that is equal to into q squared. Differentiate q squared. Again the same rule, nx n minus 1. So 2 comes in front, 2q 2 minus 1 minus 3 into 1q 1 minus 1 plus 4000. Yes, 4000 becomes 0. Because always constants become 0. Therefore, the formula is 4q minus 3. A very simple answer, 4q minus 3. Say distance and the time. So shall I write here? (26). Distance is equal 3t4 minus 2t3. Distance and time. So here we have d capital D by dt is equal 3 into 4. We can now multiply, right? 3 into 4. 4 comes to here. 3 into 4, 12. T to the power 3 minus 2 into 3, 6 t to the power 2. Now we can straight away multiply here. 4 into 3, 12, t to the power 4 minus 1, 3, minus 2 into 3. 3 comes into the front, so 3 into 2 minus 6, t to the power 3 minus 1 is 2. Another variable, say the revenue is equal (10q squared minus 4q plus 600). Revenue is equal 10 into quantity, q squared, quantity q, a simple q. So dr by dq, that is equal 10 into 2q 2 minus 1 plus 4q to the power 0 plus 0. So the final answer 10 into 2, 20q plus 4. This is 27. Now take your handout. So in your handout under differentiation, you have 18 questions. So the first couple of questions are very simple. So the first question is y is equal x to the power. So we have done similar questions now. Okay, you can do now first 6 questions, very straightforward. So second 6, okay, I'll come back to this one. Question number 12. Question number 12 of your handout. That's a bit difficult, so I will tackle it here now. Question number 12. Y is equal, question number 12 of HB handbook, x squared minus 9 divided by x minus 3 where comma sign is there, where x does not equal 3. X does not equal 3. What if x equal 3? 3 to 3 squared, that is 0 divided by 0 is not valid. Therefore, x does not equal to 3. So, how do we differentiate this one? We know that x squared and 9 we learned that is the difference between two squares, right? That is the difference between two squares. So we can write this as, so y is equal, difference between two squares, I can write this as x plus 3 times x minus 3. X plus 3 times x minus 3. So that's divided by x minus 3. X plus 3 times x minus 3, because this is difference between two squares. So x plus 3, x minus 3 divided by x minus 3 remains same. Now I can easily cancel x minus 3 with x minus 3. So the formula becomes very simple now. X plus 3, differentiate dy by dx, that is equal here 1, that's all. Because when you differentiate 3, that is 0. So the answer is 1. Okay, that is the question number 12. Okay, I will do the multiplication a bit later, but I would like to draw your attention question number 18. Question number 18. Yes. So y is equal ax squared plus bx plus c, the standard form of a quadratic equation. This is the standard form of a quadratic equation. Differentiate this one. Don't worry about the symbols, even though we have a, b and c, those are coefficients. So here we have dy by dx, that is equal, a is a coefficient a into 2x plus b into 1, c becomes 0. Because when you differentiate x, that is equal 1 plus 0. So the answer, 2ax plus b. 2ax plus b. Then going back to the next section, you have some function with the different variables. Differentiate the following functions with respect to the given variables. So you have given different variables. First question, y is equal 3t squared plus 2t minus 4. It's nothing special. Apply the same rule. Dy by dx, question number 1 of the second part. Dy by dx, that is equal 3 into 2, 6t plus 2. T becomes 1. So 6t plus 2, say 2 into 3, 6. T, 2 minus 1, 2 minus 1 is 1. 2 is a constant, so you write coefficient. T to the power 1, 1, t to the power 0, t to the power 0 is 1, no need to write 1. So the answer is this one. So you can do the rest of the questions, not difficult. Again, question number 4 is like question number 12. Question number 4 is like question number 12. And question number 5, you can expand u minus 3 into u minus 3 into u minus 3, and you can find it the answer. Okay. Now we'll look into the multiplication. So we have done addition and subtraction. So addition and subtraction is no problem. You have to hear plus sign or minus sign. Irrespective of the sign, you apply the rule as it is, no problem. But the differentiation, if you multiply two functions, say y is equal fx into gx, multiplication. We have done addition and subtraction, but multiplication we have a small rule, so we have to learn that. But for the simplicity, I will change the notation. First one u, second one v. U and v are function of x. Rather than writing fx, I would prefer to write u. Rather than writing gx, I would like to write v. So we are having y is equal uv, u into v, multiplication. So the rule is dy by dx, that is equal first function times the differentiation of second function. So u times dv by dx. What is it? First function times the differentiation of second function. U times dv by dx plus second function times the differentiation of first function. It's very easy. Yeah? First function times differentiation of second function. Yeah? First function times differentiation of second function, plus sign. Second function times differentiation of first function. First one times second one times first one. So you have to differentiate. So this particular formula is for multiplication. So we'll do some examples. Say y is equal 2x squared plus 3x plus 4 into shall I make it a simple question? First one. Question number 28. First one, y is equal 2x squared minus 4, 3x squared minus 6. The two brackets means multiplication. So we are supposed to multiply first one into second one. So what are we going to do? So dy by dx, record the rule. What is the rule again? First function times differentiation of second function plus second function times differentiation of first function. First function, what is the first function? This is u. Basically this is u and this is v. Look at carefully. First function times differentiation of second function. So you write the first function as it is. Don't do anything. Write the first function as it is. 2x squared minus 4. Write the first function as it is. Don't do anything. So 4x squared minus 4 times differentiation of second function. So that is 3 into 2. 3 into 2 is 6 into x to the power 1. Because 2 minus 1 plus 0. I don't want to write 0. Here. First function times differentiation of second function. Second function, this is a constant, always that is 0. When you differentiate this one, 2 into 3, 6x. What is the sign? Plus sign. Now, second function times, so what is the second function? 3x squared minus 6. 3x squared minus 6. Second function times the differentiation of first function, that is, when you differentiate this one, 2 into 2, 4x. 4x, that's all. So you can simplify. 6x into 2x squared, that is 12x squared. 6x into minus 4, that is minus 24x. 4x into 3x squared plus 12x to the power 3 minus, sorry, this is a mistake here, 6x into 2x squared, so that is x to the power 3. 6 into 2, 12, x squared into x is x to the power 3. This one also 4 into 3, 12, x to the power 3 minus 24x. You can see a similarity, 12x to the power 3, 12x to the power 3, that is 24x to the power 3 minus 24, 48x. So the answer 24x to the power 3 minus 48x. If you want, you can take 24x as a common factor and fine, but still this is sufficient. 29, y is equal x squared times 3x squared minus 4x minus 6. X squared times 3x squared minus 4x minus 6. So how do you differentiate this one? Again, multiplication. I would like to apply the multiplication rule. So dy by dx, that is equal first function times, so that is x squared times differentiation of second one, whole thing, differentiate. So 3 into 2, 6x minus 4, that's all. So here x squared differentiate 2 into 3, 6x minus 4 plus second function times differentiation of first function, that is 2x. So you can simplify this, 6 into 6x to the power 3 minus 4x squared plus 2 into 3, 6x 3 minus 2 into 4, 8x squared minus 12x. 6x3, 6x3, 12x3, 6x3, 6x3, 12x3, minus 4x squared minus 8x squared, that is minus 12x squared. So here this one and this one, this one and this one, then finally 12x. So that is the product rule. The product rule. So question number 30, y is equal x squared plus 1 times x squared minus 1. Could you please do this question? X squared plus 1 times x squared minus 1. Differentiate using the multiplication rule. Right. Dy by dx. So that is equal first function times differentiation of second function. So the first function is this one, x squared plus 1 times the differentiation of second one, 2x. Why? Only x squared. This is a constant. Constant becomes 0, therefore 2x. Plus second function times x squared minus 1 times differentiation of first function, again 2x. First function times differentiation of second one and second one times differentiation of first one. So now you can simplify this. 2x into 2, 2x to the power 3 plus 2x plus this one again 2x to the power 3 minus 2x. You can see plus 2x and minus 2x you can cancel. The answer is 2 to 4 x to the power 3. A very simple answer, 4x to the power 3. So a lot of theory parts, computations, but the application questions are a bit easier. So right, now there's a particular concept called function of function. Say, if you have something like, say 2x squared plus 3x plus 4 to the power 10. So differentiate this function. How are we going to do it? Power 10, that means you are going to multiply this term into 10 times. So practically not possible. You are going to multiply this term into 10. 10 times you write this and multiply. So it's a big term, right? So it's practically not possible. So there's a small, very easy technique to differentiate this one. So we call this, write down function of function. Function of function. I will explain using an example because that is the way. If I explain the theory part, you will confuse. So it's very simple. Now, just for a moment, think this is x. For a moment, assume this is x, say capital X. If this is capital X, we apply the same formula. What is our formula? Nx n minus 1 formula, right? If this is capital X, we apply our same formula and differentiate. For a moment, think this is x, right? So if this is x, this is just like y equal x to the power 10. This is just like y equals x to the power 10. If x to the power 10, we differentiate dy by dx equal 10x to the power 10 minus 1 is 9. Correct? X is, capital X is this term. And again, this is not x. Therefore, we multiply this differentiation. We differentiate this and put it here. Multiply, differentiate this one, 2 into 2, 4, x plus 3. But this is not x, so I delete this and put the function 2x squared plus 3x plus 4. That's all. That's the answer. So, something to the power 10, this can be more than 2 anything more than 2. So, we think this is x. We think this is x and differentiate nx n minus 1. Nx n minus 1 and differentiate of inside function. When you differentiate the inside function, that is 4x plus 3. Right. That's maybe question number 31. Okay. We'll do some more questions here. Using this rule, function of function, just complete this one. I don't want to simplify this because to the power of 9. Just keep it like this, that's enough. Right. The next one, y is equal x squared plus 4 to the power 5. Differentiate this function, dy by dx, that is equal, this is x, so 5x 5 minus 1, and differentiation of inside function, that is 2x. Differentiate this function, so 5, just assume this is x, so 5x 5 minus 1 and differentiate of this, that is 2x. Keep it like this, that's enough. or even you can multiply this one with this, so that becomes 10x times x squared plus 4 to the power 4. That's enough. (33) y is equal 2x plus 4 to the power minus 3, negative 1. Doesn't matter, the same rule, dy by dx is equal nx n minus 1, nx n minus 1. So since this is not x, you multiply it by the differentiation of inside function. When you differentiate the inside function, that is 2. So this is equal minus 6 2x plus 4 to the power minus 4. 34 so y is equal 2x3 minus 4x2 plus 5x minus 6 to the power 4. Find the answer, dy by dx. Find the answer. Just assume that whole thing, that is, the whole thing is x. Just assume the whole thing is x. So this is 4 2x3 minus 4x2 plus 5x minus 6 to the power 3. So nx n minus 1 multiplied by inside function, differentiation of inside function, that is 2 into 3, 6x minus 8x plus 5. 6x minus 8x plus 5. Now the multiplication questions, we can apply this. So even we can apply, I mean, this is not isolated question. So if I give you something like this, say question number 35. So y is equal 2x squared minus 1 to the power 5 times 3x minus 4. What is this one now? Now here, this is a function of function. Y to the power 5 is here. So this is a function of function with multiplication. So function of function with multiplication. So both are here. Function of function part and the multiplication part. So we apply the multiplication rule. What is the multiplication rule? First one times differentiation of second function plus second function times differentiation of first function. Apply that one. You can recall this is u and this is v. Then how do we differentiate? U times dv by dx. U times dv by dx into v times du by dx. This is the rule. We'll apply the same rule, but only thing, when you differentiate this part, function of function, that is du by dx, here we have to apply this rule, function of function rule, right? Okay. I'll do it here. Okay, the first function times here u times dv by dx, that is the first function times differentiation of second function. So dy by dx is equal 2x squared minus 1 to the power 5, right? First function times, write the first function as it is. Then the differentiation of second function here, only 3x. This is a constant, that becomes 0. Only 3x. When you differentiate 3x, that is 3. Why? X to the power 1. So I'll write it here. 3 into 1 x to the power 1 minus 1. So 3 into x to the power 0, x to the power 0, 1. So just 3. So you can write here 3. Because of this, only 3, all right? Plus second function times, that is 3x minus 4 times differentiation of first function. Now you have to apply the rule of function of function. So 2x squared minus 1, apply the function of function because of the 5. So for a moment think this is x. For a moment think this is x. Then differentiation x to the power 5. X to the power 5. If it is x to the power 5, we differentiate 5x to the power 4. Nx n minus 1. And since that is not x, we differentiate the inside function and put it here. 2x squared becomes 4x. Here 2x squared becomes, when you differentiate 2x squared, that it becomes 4x. So this is 4x. So I write here x squared, 2x squared minus 1. 2x squared minus 1. So nothing much. I can simplify here. Take 3 in front. 3 times 2x squared minus 1 to the power 5. That's the first part. Second part, you can observe this is 4x and 5 plus 20x. 4x into 5, 20x. And the two brackets, 3x minus 4 and 2x squared minus 1 to the power 4. So that's it. So I don't want to simplify because it's not suitable, because to the power 5 and to the power 4 is there. So keep the answer like this. So it's a differentiation of this function. Okay. So with that we have completed basically the basic differentiation. Okay, so this is the area where we have simple differentiation. The differentiation multiplied by the coefficient, addition, subtraction, and then the multiplication, and finally function of function. So this is the whole theory part of the differentiation, rather difficult part. But the next section we are discussing the application part of the differentiation. Application part in the sense, say for example, if we have a cost function, we need to find out the marginal cost function. So how do we find marginal cost? You may know what is marginal cost. The cost increment. That's the application part. If you know the revenue function, how do we calculate the marginal revenue? So what is marginal revenue? In economics, we learn marginal revenue. Marginal revenue, revenue increase from a given point. When you increase another 1 unit, what is the revenue increase? So marginal cost and marginal revenues are one of the application of the differentiation. Not only that, there's some more computation like calculating maximum and minimum functions. So those are again the application. So application question you never get like this. It's a very simple function. So application questions are rather easier than computing this type of equations. These equations you have a lot of terms, but the application questions very simple and calculation wise very easy, but you have to very clearly understand the concept. So today the concept, you have to remember the formula, differentiation formula, nx n minus 1. So that is the important part to remember. Maybe you are getting MCQ questions and some more for this type of computations, maybe you are getting MCQ questions. That's why I told you no need to simplify. If there are 4 answers, you can select the correct answer. Then the application questions, yes, you have to simplify. That again, you don't get this type of complicated questions for the application. Very simple question. No much terms like this, but you can differentiate and you have to simplify. So with that, we'll stop now. And the next part, I will discuss the application side of the differentiation. Thank you.